Welcome to Cloud Wizard. In this video, we're doing a complete deep dive into the Vendor Integration Hub, the system that lets your platform connect to dozens or even hundreds of external vendors through a single, unified integration layer. We'll cover how companies like Segment, mParticle, and Braze handle adapters, schema mapping, credential management, rate limiting, and delivery pipelines at scale. Whether you're preparing for a senior engineering interview or building integration infrastructure, this one is for you. Let's get into it. Welcome to Cloud Wizard. In this video, we're doing a complete deep dive into the Vendor Integration Hub, the system that lets your platform connect to dozens or even hundreds of external vendors through a single, unified integration layer. If you have ever wondered how companies like Segment, mParticle, or Braze handle outbound connections to Salesforce, Google Ads, Facebook, Snowflake, and dozens of other tools, all with different APIs, authentication schemes, rate limits, and data formats, this video is for you. We'll walk through the functional requirements, non-functional requirements, system architecture, end-to-end user journey, core models, low-level design, and the trade-offs that come up in a senior system design interview. Whether you are preparing for a FANG interview or building a vendor integration platform, let's get into it. Here is the core problem. A modern marketing or data platform needs to send events, audiences, and configuration data to dozens of external vendors. Each vendor has a different API, REST, GraphQL, SOAP, SFTP batch files, or proprietary SDKs. Each vendor has different authentication, OAuth 2.0 API keys, JWT tokens, HMAC signatures. Each vendor has different rate limits, retry semantics, payload schemas, and error codes. Without a centralized integration layer, every team builds its own connector, duplicating retry logic, credential management, schema mapping, and error handling. The result is a fragile, unmaintainable patchwork of point-to-point integrations that breaks silently when a vendor changes their API. The business needs a vendor integration hub that abstracts all of this complexity behind a unified adapter framework, so adding a new vendor is a configuration task, not a 6-month engineering project. Let's walk through the functional requirements. First, the hub must support a pluggable adapter framework where each vendor connector implements a standard interface for authentication, payload transformation, delivery, and error handling. Second, it must provide schema mapping and data transformation so that internal canonical events can be translated into each vendor's expected format using configurable mapping rules. Think field renaming, type coercion, array flattening, and conditional logic. Third, it must handle credential management securely, storing OAuth tokens, API keys, and secrets in an encrypted vault, handling token refresh automatically, and rotating credentials without downtime. Fourth, it must support both real-time streaming delivery via webhooks and APIs, and batch delivery via SFTP or file-based uploads on a schedule. Fifth, it must provide a self-service vendor catalog and configuration UI where teams can browse available connectors, configure mappings, set up credentials, and activate or deactivate integrations without writing code. Now the non-functional requirements. The hub must handle high throughput, because platforms like Segment and mParticle process billions of events per day across hundreds of vendor destinations. Latency for real-time integrations must be low, under 5 seconds from event ingestion to vendor delivery. The system must be highly available because a hub outage means data stops flowing to every downstream vendor. It must be horizontally scalable so that adding a new high-volume vendor does not degrade existing integrations. Rate limiting and backpressure must be first-class concerns because each vendor has different rate limits, and the hub must respect them without dropping data. The system must be secure because it stores and transmits credentials and customer data. And it must be observable. Every event delivery must be traceable end-to-end with status, latency, retries, and error details. Here is the high-level system architecture. On the left, upstream systems emit canonical events into a Kafka ingestion layer. A router service reads from Kafka, determines which vendor destinations are active for each event, and fans out the event to per vendor delivery queues. Each vendor has a dedicated adapter worker pool that reads from its queue, transforms the payload using the schema mapper, authenticates using the credential manager, and delivers the event to the vendor API. A rate limiter sits in front of each adapter to enforce vendor-specific rate limits. Failed deliveries enter a retry queue with exponential backoff and dead letter handling. The credential manager integrates with the secrets vault like HashiCorp Vault for secure storage and automatic token refresh. A configuration service backed by a relational database stores vendor catalog metadata, adapter configurations, and mapping rules. An observability layer collects delivery metrics, traces, and logs for every event across every vendor. The key metrics to memorize: cold delivery success rate, which measures the percentage of events successfully delivered to each vendor on the first attempt and after retries. End-to-end latency, the time from event ingestion to confirmed vendor delivery, targeting under 5 seconds for real-time. Throughput, measured in events per second per vendor and aggregate across all vendors. Error rate by error type, distinguishing between transient errors like rate limits and timeouts versus permanent errors like invalid payloads. Retry amplification factor, the ratio of total delivery attempts to unique events, which should stay close to 1. Credential health, tracking how many vendor connections have valid, non-expired credentials. And connector coverage, the percentage of requested vendor integrations that are live versus in backlog. These metrics are what the business and platform teams actually care about. Let's trace the end-to-end user journey. A growth engineer at a fintech company wants to send purchase events to Braze for push notifications, to Salesforce for CRM enrichment, and to Snowflake for analytics. She opens the Vendor Integration Hub UI and browses the connector catalog. She selects Braze, enters her Braze API key, and maps the internal purchase event fields to Braze expected custom event schema using the visual mapper. She repeats the process for Salesforce, this time using OAuth to authorize the connection. For Snowflake, she configures a batch connector that aggregates events into Parquet files and uploads them every 15 minutes via a secure staging area. She activates all 3 destinations and the hub begins delivering events immediately. Within minutes, she sees delivery confirmations, latency metrics, and a green health status for all 3 vendors in the monitoring dashboard. The core models and algorithms. The adapter interface defines a contract that every vendor connector must implement, authenticate, transform, deliver, and handle errors. The schema mapper uses a declarative transformation language, similar to JS Onata or JMES Path, to convert canonical events into vendor-specific payloads without writing custom code. The credential manager wraps a secrets vault and implements automatic OAuth token refresh, API key rotation, and credential health checks. The rate limiter uses a token bucket or sliding window algorithm per vendor, with configuration pulled from the vendor catalog. The retry engine implements exponential backoff with jitter, configurable max retries, and dead letter routing for permanently failed events. The router uses a fan-out pattern. For each incoming event, it evaluates which destinations are active and which filtering rules match, then enqueues the event to each destination's delivery queue. The key trade-off is flexibility versus performance. Highly configurable transformation and routing adds latency, while hard-coded connectors are faster but unmaintainable at scale. Now the low-level design deep dive. The adapter registry is a table mapping vendor identifiers to adapter implementations, configuration schemas, and supported authentication types. Each adapter is a stateless worker that pulls from a per-vendor SQS or Kafka partition. The transformation pipeline is a chain of composable stages: field selection, renaming, typecasting, enrichment lookups, and final serialization into the vendor's expected format like JSON, XML, or CSV. The credential store uses envelope encryption. Data keys encrypt credentials, and a master key in a KMS encrypts the data keys. Token refresh is handled by a background scheduler that proactively refreshes OAuth tokens before they expire. The delivery layer uses connection pooling and HTTP keep alive for REST vendors, and managed SFTP sessions for batch vendors. Circuit breakers protect the hub from cascading failures when a vendor API goes down. After a threshold of failures, the circuit opens and events are buffered until the vendor recovers. The dead letter queue captures events that exhaust all retries, with metadata for manual inspection and replay. Key takeaways for your interview. First, a vendor integration hub is fundamentally an adapter and routing system, so emphasize the pluggable adapter interface, fan-out routing, and per-vendor delivery isolation. Second, schema mapping is the hardest engineering problem. Explain declarative transformation languages and why they beat custom code for each vendor. Third, credential management is a security-critical subsystem. Mention encrypted vaults, automatic token refresh, and rotation without downtime. Fourth, rate limiting and backpressure are essential because every vendor has different limits and your hub must respect them without dropping data. Discuss token bucket algorithms and per-vendor queue isolation. Fifth, observability must be end-to-end. Every event must be traceable from ingestion through transformation, delivery attempt, retry, and final status. If you can walk through this system with these 5 points, you will signal strong senior-level design thinking. That's it for the Vendor Integration Hub. If this helped, like and subscribe, and I'll see you in the next one at Cloud Wizard. And that's a wrap on the Vendor Integration Hub. We covered the full picture, from pluggable adapters and schema transformers, through credential vaults, rate limiters, retry engines, circuit breakers, and the low-level design of the delivery pipeline. If this video helped you, please hit that subscribe button and the bell icon so you never miss a new system design video. Drop your questions in the comments below. I read every single one. See you in the next one at Cloud Wizard.